Hey everyone, Dr. Crayhay here. This week we're going to take a break. We're going to pause from new material and take a look back at what we've done thus far. So in this lecture, I'd like to highlight some of the things that I think are most important. Of course, it is important to understand how things are calculated and all of the nitty-gritty, those kinds of things, but this lecture I'm going to focus on, 10 years from now, assuming you're not working in statistics, what kinds of things should you still have an understanding on? What kinds of things do you need to understand to move forward in this course? And then what do I hope you'll remember once you leave this course? So right off the top of the bat, first, IV versus DV. So independent variable versus dependent variable, and the ability to discern which is which in any given research study is going to be very important. It's important for designing research studies. It's important for interpreting research studies. So remember that the IV is what the researcher changes, right? So maybe I'm interested in the effects of stress on test taking. So I'm going to put some people into a situation where they are very, very stressed, and then other people will be put into a situation where there is very little stress. That's my independent variable, the amount of stress I'm exposing these participants to. My dependent variable would be how they do on the test. So say, for example, it's a math test. Do the stressed out people do better on the math test? Do they do worse on the math test than those people in the low stress group? So the independent variable is what I, as the researcher, change. The dependent variable is going to change as a result of the IV, so changes because of the independent variable. So the dependent variable kind of depends on the IV, so that's how I remember it. So the DV depends on the IV. The IV is what I change as the researcher. I've linked in our course resources a Zaption tour on this, so it's a little quiz where you go through and you have to identify the variables. You identify which is the IV, which is the DV. I think you're also asked to identify the type of claim. So we don't talk about that in statistics, but the other stuff is definitely relevant. If you feel like you need a bit more practice, please do see those course resources and go through that if you'd like. The next is descriptive versus inferential statistics. So remember, descriptive, describe. So descriptive, describe. They are going to describe a sample. So everything that we've talked about in the course thus far has been a form of descriptive statistics. So we've got mean, median, mode, variance, standard deviation, we've got z-scores, we've got all of those things that we've talked about thus far. Descriptive statistics, we're just describing what's going on. Inferential statistics, we will head there very, very soon, and we will stay there for the rest of the course. Inferential statistics are going to try to generalize to a larger population. So you collect a little bit of data, you want to be able to speak about a population. These will always include, well, not always, they will typically include p-values. In this class, they will always include p-values. It does get a little bit more complicated when you get into more sophisticated statistical analyses, but in this course, inferential statistics will always include p-values. Again, there's a supplemental lecture that talks solely about this, these ideas, these two terms, so see course resources if you want some more on that. The last thing on my list right here for the first couple of chapters, discrete versus continuous data. Remember, discrete means you're in one category or you're in another, so things like gender, class status, those kinds of things. So you're in one category or another. Continuous can be any possible number along a row, right? So age is a really good example because you're 25 in 3 months or 4 months, and you could go down to I'm 28 years old with 3 months and 14 days, right? So if we really wanted to drill down into that data, we could. Height is the same way, so we tend to round, you know, I'm 6'2". Realistically, you're 6'2", maybe a little bit of change there, right? So we're rounding. Continuous can take about any number along a continuum, just about any number. Discrete, you're either in one category or you're in another. Again, there are supplemental videos linked in course resources. If you feel like you need some more on that, please do see those. Moving forward, we talked about some visual displays of data. So one of those things was a histogram where you have frequency over here, and then you're going to kind of graph your variable down here. This point should always be 0. So as you're moving forward in your careers, notice when these charts, when these figures that people are publishing, notice when they start at different numbers than 0. There's a reason for that. So take some time, think about that, and pay attention to when you see those. Best practice, though, is to start at 0. Now, depending on what kind of variable I have right here, we'll use either a histogram or a bar chart. Let's say, for example, I want to plot final exam scores for a statistics course. So this is a continuous variable because you could get any percentage score from 0 to 100 on that final exam. So on the left here, we've got frequency of 0 all the way up to, I don't know, say we have 100 students or something like that. So this would be 50 as well. So what we're going to do here is for every person that got a 50, we're going to draw a little box. So maybe we had, you know, quite a few people that got 50s. Maybe we had some people out here that scored 100. And so you just kind of keep filling this in with your data, right? So they can touch. And most likely, if you have a large enough sample, you'll end up with a normal distribution that I'm drawing very poorly. You know, it'll be much prettier than this. So you can have any score along here, and you're looking to see what's the most frequent score. Well, the way I was trying to draw it was to make the most frequent score be 50, right? But a histogram gives you that information. If we had a different form of final exam score, say we wanted to know letter grade. So here we would have how many A's, how many B's, how many C's, D's, and F's, right? So then for every one, we just kind of draw how many people. So in this, we have what's called a discrete variable. Up here, remember this was continuous. Discrete, you can be in one category or another. So you either have an A, a B, a C, D, or an F, and we look at how frequent each of those is. Most people are in the C range, so that's supposed to be about average, right? So this is a bar chart. Bar charts are used with discrete data. This is a histogram for continuous data. So these are essentially the same thing, except with one we have a certain kind of data, with another we have a different kind of data. Using a histogram, we can tell if we have issues with skew and kurtosis. So we've started to talk about normality by now, so hopefully you have a better understanding of skew and kurtosis. This is something that will keep coming up, but visually you can look. If you have a data set that looks like this, let me scroll up a little bit to include the top of the distribution. You could also have a data set that is looking like this, right? So you've got some tails that are pointing out. So this has negative skew, this has positive skew. Kurtosis, it might be a very tall and flat distribution. It might be very small and flat. So those are skew and kurtosis. They're assessing normality. So skew and kurtosis. Visually, you can look at it and you can say, oh, look, my histogram looks kind of weird. What should I do about that? The other kind of graph that we will use over and over again is called a box and whisker. So this is how typically I use these to identify outliers. They're very good for that. So in SPSS, you'll get a nice looking plot like this, where you have a box right? Typically that box will have a line right in the middle. And then you have these little whiskers coming off, right? These little points that give you a sense of the variability of your data. So in these box and whisker plots, if you have something down here, like a little asterisk, that is what's called an outlier. Outliers can skew our data quite a bit. So oftentimes we want to remove those people. Maybe they were lying on our survey, or perhaps their data was miskeyed. For whatever reason, they're not like most of the data, so they can cause some problems. So we'll use the box and whisker quite a bit to check for outliers. Histogram bar chart can be visual detection of normality, skew, kurtosis. This might actually give you a sense of your outliers as well. And there are additional lectures and resources on histograms, box and whisker plots, and bar charts. Okay, so moving kind of to this section right here in the middle about central tendency, mean, median, mode, the good, the bad of each, and when to use each of these. So remember, you should always report at minimum your mean and your standard deviation anytime you're reporting descriptive statistics. So make sure you jot that down on your notes if you don't have it already. The mean is very susceptible to outliers. So the mean, susceptible to outliers. So if there are outliers in your data set, it can artificially inflate or pull up your mean. It can artificially pull it down, so that is not a good thing. If you have a lot of outliers, you'll want to use the median. So with outliers, I recommend you use the median. Oftentimes what I will do, I'll do my best to bring that data to a more normal distribution, get rid of outliers if I can justify doing so. But if I can't, in that case I would report the mean, the median, and the standard deviation. The distance between the mean and the median tells people that you didn't have a normal distribution. It tells people the shape of your distribution essentially, and they can use those two numbers to make a judgment about your numbers. So the mean is definitely the gold standard. That's what we use all the time. If you have outliers, try to kick them out if you can justify that based on your data set. If you kick them out, choose not to, perhaps that didn't do anything for you, then I would recommend reporting the mean, the median, and of course the standard deviation. The mode, again, not horribly useful, but if you do have discrete data, if you're describing your population, describing your sample, you can use mode to tell what is most frequent, right? So if you're describing sample, I would use the mode to say most people were a junior in my sample, or whatever you're doing there. So mean, median, mode, when to use each, the effect of outliers, those kinds of things, that's going to be very important as you move forward in your careers. Okay, variance tables. These are very important because we'll be using them all the time to calculate different statistics, right? So these I'm going to be a little bit more strict on. I think you need to know quite a few additional details. So I'll pause here and ask some questions because I'm thinking you're going to see this again. Now, whether you do this in Excel or by hand, I do not care. It really doesn't matter. I prefer to use Excel. I know that other researchers prefer for you to use Excel. I'm never going to hand calculate anything, but using Excel is a skill that employers would like, whether we're talking about graduate school or working out in the real world. So I encourage you to do these in Excel, but of course you don't have to unless I specify. So in this first row, we have our raw scores, right? And then we take our raw scores minus the mean, and then we square the raw score minus the mean, right? So there are some terms for what we're doing here, and it is very important that you understand what each of these columns is doing. So let me just label these real quick. because I might actually, it's very possible that I would include this on your midterm exam, a multiple choice, something like this with this drawing, and say, what does A represent? What does column A represent? So let's do that real quick. So here, raw scores, this is sum, right? So we're going to sum all of those raw scores. And then down here I put the mean. So if you take the sum over n, that's how you find your mean, right? So probably you'll want to remember that formula. I think that will be very easy for you to remember, or just jot it down at the top of your notes so you can remember that. But here, column A, I've told you multiple times now what this is. So let's pause real quick. What's in column A? What do we put in column A? Right, so our raw scores are coming from column A. I'm going to pause real quick and ask what column B is. So these are a type of score. So we're taking the mean from the raw score. So we're seeing how much the raw score deviates from the mean. What are these scores called? Good, so B is, these are deviation scores. So let me write this down for you. A is raw scores. B is deviation scores. Column B are the deviation scores. So these are how much those raw scores deviate from the mean. In C, we're taking results from B and squaring them. So what is C called? Good, so C squared deviation scores. Down here, we're taking the sum of those deviation scores in column B. This number right here should always have the same value. What should the value of D be? It's the sum of the deviation scores. So sum of deviation scores should equal what? Should always equal 0. Because the mean is the mathematical average. It's the mathematical balancing point such that exactly half the scores are above, half the scores are below. So if you subtract the mean from everything and then sum up those deviations every single time, you should get 0. If you don't, something has gone wrong. With E here, we've got our column C, which are our squared deviation scores, right? So we're taking these deviation scores, squaring them, we're summing them here. So what do we call column E? Right, so this should be sum of squares. Now this is really important because we use the sum of squares to start to calculate our variance. So variance, I'm not going to use the symbols, I'm just going to write out variance equals sum of squares over n minus 1. To be more specific, this is our sample variance. So sample variance, sum of squares over n minus 1. I would recommend that you save this. Write it at the top of your worksheet, on your notes, wherever you need it. I would keep that very, very handy. Now, we don't tend to use variance very much in the day-to-day, so what we'll do is we use standard deviation. And again, I'm going to simplify this for you. Sample standard deviation is just the square root of the variance. So when we use this variance table, I think it simplifies those calculations a bit for us, particularly if we do this stuff in Excel. So please make sure you know this table, make sure you know what this table is doing. We will see this again. Moving forward to the normal distribution, this is a central idea when we get to hypothesis testing. So please, please, please take some time, think about the normal distribution, think about what it is. The basics are that as we collect more and more behavioral data, we find that it conforms to what's called a normal distribution, such that the mean, median, and mode are typically right in the center. So this might be the mean. This line right here is +1 standard deviation, -1 standard deviation, -2 right there, +2 right here. Because we know the shape of this curve, because we know the proportions under it, we can start to make some educated decisions based on these percentages. So we know 50% of scores are above the mean. We know that 50% of scores are below the mean. We know that about 34% are right here, and so on and so forth. That's all I remember off the top of my head. Because we know the percentages at each step of this, we know where the most likely events are to occur. So no matter what you're doing, most people are going to fall into this shaded area that I'm shading right here. So actually about 60, I think 68%, if I'm remembering my numbers correct, 68% will be right in here. So this becomes very important next week when we start talking about hypothesis testing, because we're basically looking at the probability of events. And what we're going to do is say, you know what, if something falls out here or more extreme, or out here or more extreme, we're going to say that that's so unlikely that we've provided some evidence for something. Now, we'll talk about that in the future, but make sure before moving forward that you understand that things out here, scores out here in these edges, are very, very unlikely to happen. That's important moving forward. Some general things that you might want to know, some of the symbols. So, you know, we're going to deal with samples in this course. So you've got mean, standard deviation. I gave you a couple of formula, right? So sum of squares over 1 over n minus 1 for variance. Standard deviation is the square root of variance. We had a couple of those kinds of things. So I think I also gave you the mean, the sum of x over n. Really, these are going to be the most important things, assuming you can remember how to set up that variance table. Moving forward, I'm going to do one more video for this review week, and I'll show you how to do all of these things in Excel, how to do them in SPSS. So if you have any questions, as always, send me an email.